Multiple NASA telescopes recently observed a massive black hole tearing apart an unlucky star that wandered too close. Located about 250 million light-years from Earth in the center of another galaxy, it was the fifth closest example of a black hole destroying a star ever observed. Once the star had been thoroughly ruptured by the black hole's gravity, astronomers saw a dramatic rise in high-energy X-ray light around the black hole. This indicated that as the stellar material was pulled toward its doom, it formed an extremely hot structure above the black hole called a corona. NASA's Nuclear Spectroscopic Telescopic Array satellite is the most sensitive space telescope capable of observing these wavelengths of light, and the event's proximity provided an unprecedented view of the corona's formation and evolution, according to a new study. Most black holes that scientists can study are surrounded by hot gas that has accumulated over many years, sometimes millennia, and formed disks billions of miles wide. In some cases, these disks shine brighter than entire galaxies. Even around these bright sources, but especially around much less active black holes, a single star being torn apart and consumed stands out. And from start to finish, the process often takes only a matter of weeks or months. The observability and short duration of tidal disruption events make them especially attractive to astronomers, who can tease apart how the black hole's gravity manipulates the material around it, creating incredible light shows and new physical features. The focus of the new study is an event called a 2021 EB, which took place in a galaxy with a central black hole about 10 million times the mass of our Sun. During this tidal disruption event, the side of the star nearest the black hole was pulled harder than the far side of the star, stretching the entire thing apart and leaving nothing but a long noodle of hot gas. Scientists think that the stream of gas gets whipped around a black hole during such events, colliding with itself. This is thought to create shock waves and outward flows of gas that generate visible light, as well as wavelengths not visible to the human eye, such as ultraviolet light and X-rays. The material then starts to settle into a disk rotating around the black hole like water circling a drain, with friction generating low-energy X-rays. In the case of a 2021 EB, this series of events took place over just 100 days. The event was first spotted on March 1, 2021, by the Zwicky Transient Facility, located at the Palomar Observatory in Southern California. It was subsequently studied by NASA's Neil Gehrels Swift Observatory and Neutron Star Interior Composition Explorer Telescope. Then, around 300 days after the event was first spotted, NASA's Nuclear Spectroscopic Telescopic Array began observing the system. Scientists were surprised when Nuclear Spectroscopic Telescopic Array detected a corona, a cloud of hot plasma, or gas atoms with their electrons stripped away, since coronae usually appear with jets of gas that flow in opposite directions from a black hole. However, with the 2021 EB tidal event, there were no jets, which made the corona observation unexpected. Coronae emit higher energy X-rays than any other part of a black hole, but scientists don't know where the plasma comes from or exactly how it gets so hot.